position vectors. Okay? In a diagram, we have vector AB. I'll turn the pen on. Okay? Vector AB goes down there. Now, I said earlier that vectors go from the origin. AB doesn't go from, connecting A to B doesn't go from the origin. Okay? So we have to say, how would I get from A to B via the origin? Okay? So if I wanted to get from A to B, imagine that's got a road closure. You would go down A going against the arrow. If you go against the arrow, that actually becomes minus A. And then you would go up with the arrow on B. Okay, which is positive B. So that says that you end up with minus A plus B. We also know that is B minus A. So in order to find the components connecting two coordinates, in order to find the components of the vector connecting two coordinates, we do the second coordinate minus the first. Okay? So in this example, for example 7, we are working out vector LM. Oh, I'm going back to blue. Oh, let's go back to purple. I liked you purple. Okay. Now, so we're working out vector, I need to move this down, sorry. LM. That is saying M minus L. It's usually lowercase rather than capital. I just wrote them too big, sorry. Right, so we're M minus L. Position vector M minus position vector L. Note how the M was second in the vector, so we write it first. So that becomes minus 5, minus 3, minus 1. Take away 4, minus 7, 2, which was the vector L, or the components of L. Okay? So we would do 5 minus 4 is minus 9. Minus 3, take away minus 7, becomes positive 4. And minus 1, take away 2 is minus 3. And that is your components of LM. That's all it is. So always second, take away first. Okay? Now, by that own bit, we can use that to work backwards. Example 8 is P has the coordinates 3, 7, minus 4. Vector PQ has the components minus 4, 9, minus 3. Find the coordinates of Q. Now, Q actually has, we've got a wee diagram. Q actually has the coordinates X, Y, Z. That's how I think about things, okay? And we know that PQ is the same as Q minus P. But we also know that that gives us minus 4, 9, minus 3. So we know that X, Y, Z minus 3, 7, minus 1 gives me minus 4, 9, minus 3. So X take away 3 gives me minus 4. I'll write that over here. Y take away 7 gives me 9. And Z take away negative 1 gave me minus 3. So that means that X, what take away 3 gives me minus 4? Well, take the minus 3 over. Becomes minus 1. So that's minus 1. For Y, take the minus 7 over, add it on. Or what take away 7 gives me 9? Would be 16. That becomes plus. So what, z plus something. No, what? Z plus 1 gives me minus 3. So z is minus 4. So that means that Q is minus 1, 16, minus 4. Now, if it says coordinates, your answer actually has to have coordinates and a bracket. Okay, now, again, you could do all that in your head if you wanted. We'd rather you didn't, because we like to see what you're thinking about. But that one was straightforward. Now, example 9 is unit vectors. Okay? The easiest way I could explain this is if I say I've got a line that's 5 centimetres long. Okay? The units is centimetres. But what does 5 centimetres actually mean? It means that this is broken up into 5 chunks of 1 centimetre. But how did I know it was 5 chunks? Because of the number. Okay? So, in order to find a unit vector, right? Because on this one, you could also say that that was 1/5 of 5. Where 5 is the length. Because 1/5 of 5 is 1. Okay? So, to find a unit vector, which is a single portion with a magnitude of 1, we need to work out what the magnitude of the vector actually is first. Okay? So the first thing we need to do is find the magnitude of h. And the magnitude of h, remember, Pythagoras. 2 squared. Now, can I just remind you that you don't need square roots? You don't need negatives, sorry. You need a square root, you don't need a negative. So just don't write them in. Okay? So, Pythagoras, 3D Pythagoras. Square the numbers. Add them together. Gives you 2 squared plus 3 squared plus 7 squared is 49. Oh, wait. Aye. So it's root 49, which is 7. Okay? So the unit vector of h is equal to 1 over the magnitude of h times the components. So our first step had to be finding the magnitude, which was 7. So it's 1/7 of 2 minus 3, 6. Because it said the magnitude had to be 1, that's 7 units. I need 1 unit, so I have to divide by 7. Okay? So to turn 7 into 1, you divide by 7. That's where this comes from. Now, if we want the components, we actually need to write it as components. Leaving it as 1/7 times that is not enough. 1/7 times 2 is 2/7. Oh, that's a bit small. Apologies. Is 2/7. Minus 3 times a 7 is minus 3/7. And 6 times a 7 is 6/7. And yes, I've written the lines slanted. And that is a unit vector of h.